Hi everyone. In this video we'll be looking at interpreting graphs. We'll be looking at point graphs, line graphs and linear graphs. This first graph is a point graph. You can see on the graph that we have 4 students. Each student is represented by a point on the graph. On the axes we have our 2 variables. Our first variable is the age of the student and our second variable is the height of the student. For each student, I can learn something about their age and their height. So for Darren, if I want to know about his age, I'm going to go down here and read his age from the horizontal axis. If I want to know about his height, I will go across here to the vertical axis and read it there. So we are asked to rank each student from tallest to shortest. Now, if we want to know about the height of the student, I have to look at the graph vertically this way because height is on the vertical axis. I look to see which student is the highest on the graph, and I can see Chris and Tim are very close, but if we look at Chris's height, it's a little bit taller or a little bit higher than Chris's height. So Chris is the tallest, Tim comes next, then Jack, who's considerably shorter, and Darren is much shorter. So from tallest to shortest, we have Chris, Tim, Jack, and Darren. If we want to know and rank each student from the oldest to the youngest, I'm going to look at the graph horizontally like this. I can see that Tim's point is furthest along the horizontal axis. So he is the oldest. Next comes Jack. And then we have Chris and Darren. You can see that their points are directly underneath each other, which means that their age is exactly the same on the horizontal axis. So the tallest student will be Tim, then comes Jack, and then Chris and Darren are the same age. So we have a multiple choice question here that we're asked to answer. Which of the following is shown in this graph? A, Jack is the tallest. No, Jack isn't the tallest. We just saw that Jack is not as tall as Tim. Chris is the oldest. No, Chris is not the oldest. We can see that Chris is not as old as Jack or as Tim. Darren and Chris are the same age. Yes, that appears to be the case. As we said earlier, their 2 points are directly underneath each other. So they look like they are exactly the same age on the horizontal axis. Tim is the tallest. Tim is close to being the tallest. We saw earlier that his height was not as large as Chris's height. So Chris is the tallest, not Tim. So our correct option here is C. Darren and Chris are the same age. Our next graph is a line graph. This particular line graph tells us about an ice cream shop owned by Yupa. It shows his profit for the first 4 months of the year. So our 2 variables here are profit and time. We're asked in which month did Yupa make the most profit? Well, we can see that in January, the graph is at its highest point on the vertical axis. So in January, we have the most profit. As time progresses, describe what happens to Youper's profit. Well, we can see that we've got the highest profit in January. In February, my profit isn't as high. In March, it's not as high again. And then in April, we have the least profit. We can see that the graph is decreasing as time goes on. So we can see that as time goes on, Youper's profit is decreasing. This graph is a linear graph. Unlike the previous graph that was drawn in segments, so we'll just have a look at it again. It was drawn in segments, so we have one segment from January to February, another segment from February to March, and another segment from March to April. And you can see that this section here isn't as steep as these two sections. So this isn't a linear graph. It's not a straight line. It's a little bit bent. Here we have a linear graph because for the whole graph we can see that it is a nice straight line. Now this graph is showing us the cost in cents of a phone call as time goes on. So our two variables here are time. Now time is in seconds and cost, which is in cents. We're asked to describe the relationship between the length and cost of a phone call. Well, we can see here that as time goes on in seconds, our graph is increasing. So the cost increases as time goes on. And that makes sense because we all know that the longer that we talk on the phone, the more it's going to cost us. So as time increases, cost increases. But more specifically, what is the connection fee? In other words, before I even start to talk to my friend, it costs me something just to have my phone connected to his or her phone. If we look at the graph and we look at this point here on the graph, where the graph it touches the vertical axis, we can see that the value is 25. This is telling us that the cost of just connecting to my friend is going to cost me 25 cents. Before I even start talking to my friend, I have to pay 25 cents. After that, I'm then charged a certain amount of money for every second that I talk. My next question is about that. What is the cost in cents per second? To work this out, I have to look carefully at the graph. If I look at this point up here, I can see that I have been talking for 200 seconds and my cost is 425 cents. Remember down here, before I even started talking, it was costing me 25 cents. So I need to take 25 cents from 425 cents, which is 400 cents. So to talk for 200 seconds on the phone, it costs me 400 cents. So I now need to work out 400 divided by 200. 400 cents divided by 200 seconds. 400 divided by 200 is 2 seconds. So, not 2 seconds, it's going to be 2 cents and it's going to be, I'm being charged 2 cents for every second that I talk. So it's going to be 2 cents for every second that I talk. And I read that from the graph. If it costs me 400 cents to talk for 200 seconds, then it must be 2 cents for every second. This graph here is known as a distance time graph. We have two variables. One is time, and that's on the horizontal axis, and the other one is distance, which is on the vertical axis. We're asked to draw a distance time graph for this situation. A man is going out to take his dog for a walk. He stops at the paper shop to buy a newspaper. Then he returns home. So we need to think carefully about where he starts. If he's taking his dog out for a walk, he has to start at home and no time has passed. So his starting point is here on the graph, which is the origin. No time has passed and he has covered no distance. So the first thing that he does is he starts from home and he walks away from home so that his distance away from home increases. He does this as time progresses. So time progresses this way as his distance increases. So the first part of his journey might look like this. He might walk to a certain point here. Now that should be a straight line. It's very crooked, but I haven't got a ruler to rule it. So in this section, he is taking a certain amount of time here to cover this amount of distance. If time was in minutes, I might say that this is 1 minute and this is 2 minutes. I could say that my distance was in meters, so I might say that this is 10 meters, this is 20 meters, 30 meters, 40 meters, and 50 meters. So in this section, he has taken 2 minutes to walk 50 meters. He's a very slow walker. Here is where he stops at the paper shop. He buys a paper. Now say it takes him 2 minutes to buy the paper. That section would look like this. Okay, because in this 2 minutes, he's not travelling any further distance away from home. He's actually stopped, he's stationary. And this stationary value is shown by a horizontal line. So after another 2 minutes, he starts to go home. And he has to remember we want to decrease our distance from home as we walk towards home. So he might walk like this. And now he's back at home. So if this is 5 minutes and 6 minutes, and this is a little bit more than 6 minutes, it's taken him perhaps 6.5 minutes to get home, to go to the shop, buy his newspaper, and come home again. It's important to remember that when I am walking away from my starting point, I am walking away from the horizontal axis. If it's taking place over time, my time progresses away from the vertical axis. When I stop and I'm not moving anymore, I get a stationary line over the time, a horizontal line over the time where I am stationary. And then when I want to walk back to my starting point, I need to walk back towards home here. So let's look at this next situation. We are asked to describe what happens at each point. Now, pretend this is a student at school. Here is where they are at the start of their journey, and they are at school. Down here is home on the horizontal axis. So at this point, they are 6 kilometres from home. They start to walk towards home. And when they get to this point, that has taken 4 minutes, 4 minutes on the horizontal axis. So they start here at school, they start to walk home, and after 2 minutes they stop here because they meet a friend. Their friend talks to them for 2, 4, 5 minutes. When their friend is talking to them, they tell them that they have maths homework, and they remind you that you need your maths book. So you decide you have to go back to school to pick up your maths book from your locker. To go from here back to school, it takes me 1 minute, 1 minute on the x-axis. I then go to my locker, and here is where I collect my book. It takes me 2 minutes to get my book out of my locker. Then I start to walk home again until I get to this point. This takes me 6 minutes. When I get here, I decide to walk back another kilometre to maybe the bus stop to check the bus timetable. Then I walk home. So, what's happening at each of these points? Well, here is where I am at school, ready to come home. Here is where I stop and meet my friend and chat. I stop for a chat with my friend. What happens here? This is where I'm back at school and I am at my locker. What happens here? This is where I go back the 1 kilometre to look at the timetable, the bus timetable. And then over here is when I arrive home. So, how long has it taken me to get home? It's taken me from here, it's taken me 24 minutes to get home altogether. So this is what's known as a distance time graph, and you have to read it very carefully. With these graphs, we have time on the horizontal axis, distance on the vertical axis. And we need to read what's happening, the motion of the person or the motion of the object over time. I hope this makes interpreting graphs a bit easier. Thank you.